All right, here we go. So we want to graph sine and cosine. We're going to take the circle of life and put it into play. We're going to say that that's the theta value, and that for the xy coordinate of the terminal points, this is going to be the y coordinate. And so we start here. How far is one revolution around the unit circle? 2 pi. Don't worry if you don't remember. We just tested on it yesterday. So, where is sine positive? First and second, and it's negative in the third and fourth. So therefore, it takes 4 quadrants for sine to repeat itself, doesn't it? So we're going to divide this up into 4 quadrants. And if the graph is positive, we know it will be above the x-axis. If it's negative, we know it will be below the x-axis. So we divide into fourths, we can see we have pi over 2. And then to get the third tick mark, we always take the first tick mark and multiply it by 3. And so that would be 3 pi over 2. Here we go. We're going to travel around the unit circle. We're going to start at 0 radians. What is the y value of that terminal point? 0. What is the y value of the terminal point at pi over 2? 1. What is the y value at the terminal point of pi? The y value. 0. What is the y value of the terminal point at 3 pi over 2? Negative 1. There it is. Now, there's a question here, and so I'm trying to work through it. I'll allow it to be asked again. We were confused there for a moment. No, I won't. All right, there we go. So you can see the shape that I get. I get a wave, which is really important because can you think of anything that travels like a wave? Light, sound. There's actually a sine function that we could come up with that describes how my voice is traveling from my mouth to your ears. In fact, does anybody take a forensic science class? So anyway, it continues on the other side as well. So negative 2 pi, negative pi over 2, negative 3 pi over 2. And if you follow the pattern of the wave, you can see that it will continue to produce that on the other side. Some of you guys have really good kind of rolling hills. Other you guys have like these pointy mountains for a graph. I'm not talking about anybody in particular. So the question is, over the interval from negative 2 pi to positive 2 pi, what is the maximum value that sine has? The maximum value is 1. What's the minimum value? The amplitude is the distance from the middle to the top or from the middle to the bottom, and that distance is 1. The period is how long it takes to repeat itself, and its period is 2 pi units before it repeats itself. I see looks of exhaustion and anger. Okay, it's all right. It's okay. Just put that on the shelf, and we'll get to it later. Yeah. Now we get to do cosine of x. The period is 2 pi. So here's what we have. Cosine, we're going to have another graph. But instead of looking at the y values, we look at the x values. We know that cosine also requires 4 quadrants to repeat itself. Who could tell me where is cosine positive and where is cosine negative? Cosine is positive in the first and the fourth, and it's negative in the second and the third. So I know we're going to have the graph is going to be above the x-axis, then below, then above. Let's start with 0 radians. What is the terminal point? What is the x value of the terminal point at 0 radians? The coordinate is 1, 0. What's the x value? 1. What is the x value of the terminal point at pi over 2? 0. What is the x value of the terminal point at pi? -1. What's the x value terminal point at 3 pi over 2? 0. What is the x value of the terminal point at 2 pi? 1. And so you can see we're above, we're below, we're below, we're above. That matches what you said about positive and negative. And that shape continues on the other side. Does it look similar to your sine graph? It's a wave. It's just shifted pi over 2 units horizontally. They are the same graphs otherwise. All this stuff stays the same. Still has an interval of -2 pi to 2 pi. Over that interval, a max of 1 and a minimum of -1, an amplitude of 1, and a period of 2 pi. Those are basic. I will get you, by the end of this class, to graph y is equal to -3 secant of 4x minus pi over 2 plus 1. I will teach you how to graph that. We are nowhere near being able to graph that, but that's what we have to be able to get to. Sam's freaking out. Yes. You guys, you got to trust me. This is the highest scoring test of the year. Okay? Yeah. I'm positive. Follow me step by step. Questionable. So, what happens if we put some extra numbers in with sine and cosine? Well, that's going to change the amplitude, how high it goes up or down. Okay? So if I raise my voice, the amplitude goes up. If I lower my voice, the amplitude is down. How do we determine the amplitude? It's the absolute value of the number in front. You guys are kind of high maintenance today. Not the boys, just the girls. And then the bottom absolute value of A. The period is 2 pi, but if you put a b in front of the x, it's 2 pi divided by b for each of them. Now we're going to practice graphing those functions, knowing that the amplitude is the absolute value of A and the period is 2 pi divided by b. You should know that on your test, you get to use this sheet of notes. So on the back, as you see this sheet of notes, You can see that sine and cosine, all those things are delivered right there for you. Right. I do. Here we go. Turn to this page. I could tell. Amplitude. What is the amplitude of, we're going to start with y equals 3 cosine of x. Amplitude is 3. What is the period? The number in front of x is 1, so 2 pi over 1 is 2 pi. So I'm going to mark off 2 pi. How many sections do I divide 2 pi into? Why 4? Because there are 4 quadrants. Yep. No stupid questions. Okay. The period is 2 pi divided by b. B is the number that sits in front of x. The number that sits in front of x is 1. So 2 pi divided by 1 is 2 pi. We good? All right, the amplitude is 3, so I go up 1, 2, 3. Negative 1, negative 2, negative 3. And I have a cosine graph. So let's figure out how this thing starts. Do you remember what the cosine of 0 is? What is the x value at 0 radians? 1. And then it says to take that multiplied by 3, so you get 3. So if you notice, cosine likes to start at the maximum. Where do you think it will go from there? Down. Then it will bottom out, head back up, and it will repeat that same shape on the other side. Logan is going to do his best to sketch something that has a little bit more curvature to it. Takes practice. That's one of the classes you take in college is learning how to sketch sine graphs. So I'm totally lying about that. That's a joke. Good job. I can. Let's look at y equals negative sine of x. I identify the amplitude, and I identify the period. What is the amplitude? Amplitude is always positive because it's an absolute value. What is the period? 2 pi. No, I just use my freedom of, choice of mathematics. Something you're allowed to do in America. Yes. The amplitude is always a distance. So so we say it's positive. Okay. I mark off 2 pi. I divide it up into 4 quadrants. Because that's how long it takes for sine and cosine to repeat. Zero. The sine of 0, the y value at 0 radians. 0. Make it negative and it's still 0. From there, where do you think we go? We don't go up. because the negative sign creates a vertical reflection. Negative on the outside creates a vertical reflection of the graph. So instead of the graph going up, the graph is going to start by going down. No big deal, right? Okay. Thank you, Willie. Then if you guys said what you said, which is you don't know what's going on, you're just following what I'm doing, then we need to switch roles. You do the problem, and I will follow along. Trust me, you guys will be able to do it. I start by identifying the amplitude. You tell me, what is it? 4. Oh, wow, you do know what's going on. What is the next thing I do? What am I doing? What is that? What? It's the period. And the period, you came up with what, Emma? 2 pi over pi. Oh, I took 2 pi and I divided by this guy, which was pi, and you got dos, which is Spanish for 2. Good job. Okay. What else do you want me to do? Oh, it's just 2. Oh, it's 2. Oh. That's what I tried to do. I'm trying to trick you. Like, that was my best effort. Couldn't come up with anything else. Just no pi involved, right? Because the pi divide off. So we just got 1 and 1/2 and 3/2. Yeah. Oh. Ah! I'm sorry, YouTube, but one of my students said they were happy that pi was gone. That way we actually have numbers now. And so not acknowledging pi as a number, it breaks a math teacher's heart. It's like they think it's Thanksgiving, it's dessert or something. I don't know. All right. I don't know what to do. I need your help. Sine starts at 0. Okay. All right. So Noah asks an excellent question. Okay. And Emma gave the exact answer. 0 radians has a coordinate of 1, 0. So that's what we're doing. This is a theta value of 0. That's for an angle of 0. That's always where you start. And the sine value is y. So it starts at 0. And to show now how much you guys understand it, you're going to help me do the next one because I know I will give you a second. I will. I'm just the people on YouTube are waiting in anticipation to see what comes next. My goodness. Okay, since Samantha is ready, we can all start. So, you take it away. Guide me through. Now what? 2 pi divided by, what's the number in front of x? 1/3. 2 pi divided by 1/3. How do you do 2 pi divided by 1/3? And you get 6 pi. Six pi? Negative 6 pi. Uh-oh. Now what? Okay, you could do the 2 and the negative 2. All right. Good job. We got that. Now what else? 3 pi. Okay, I like 3 pi in the middle. Okay, so I can do the negative 3 pi. Okay, now what? I need more quadrants than that. 3 pi over 2. I like that. Does that make sense? If you think about that, half of 3 pi is 3 pi over 2. So I got to get this spot. What do I do to get that spot? 9 pi over 2. It's 3 of those, right? So 9 pi over 2. 9 pi. I've Caroline in class from Germany, and so many times I would say 9 because it's German for no. So yes, we're still working on that like humor relationship piece of. Sometimes I worry that she thinks I'm making fun of her, but I'm totally not. Totally not. Okay, I don't know what to do. I need help. Oh, let's see here. Let's go back to where Noah was, and Noah said that if it's cosine, it's going to be the x value or the y value. It's going to be the x value. So the cosine of 0 gave us 1, and then you multiply it by negative 2, so it'll start at negative 2. Yeah. See, sine always starts at the middle. Cosine starts at the max or the min, depending on if it's positive or negative. So we're doing cosine, right? So cosine is the x value, so 1, and negative 2 times 1 is negative 2. Then we head on our way up. Go through and make our dots and do all that cool stuff. Are you hanging in there? So let's not do the very last example, but let's do just this one right here. Because we're going to put both graphs on the exact same set of axes. Okay, wow. People are shutting down YouTube Nation like, wow. It's like when your computer goes into safe mode. It's like energy gone, quickly shutting down, plug in if you don't want to lose any information. And we're going to do our best to retain. So we're going to list the amplitude, which is 2, and the period, which is 2 pi. Hey, sounds like everybody knows what they're doing. I'll look at the bottom one. The amplitude is 6, and the period is pi over 2. Because I take 2 pi over 4, which is pi over 2. Awesome. Now I need to make both of these fit on the same axes. So because my teacher told me to. See, I actually used to not have people do this, and then I realized they were getting these type of questions wrong on the ACT. I was like, well, how are they getting it wrong? They all know how to graph them, but after a while, don't they look the same? Well, now when we put them on the same set of axes, you can start to see how they're different. And those are the type of questions you'll get on the ACT. So let's look at it. We're going to look at, I have to mark out 6 for the amplitude because it goes all the way up to 6. And then the period goes all the way out to 2 pi. And so I choose the largest values to be able to fit the graph. I can divide it up into just, pi, pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. And now the question is, which one should we start with? And it's actually easier to focus on the one that stretches the entire period. So we've got 2 pi here. So I'm going to graph y is equal to negative 2 sine of x. Where is it going to start? 0. Is it going to start by going up or down? To which value? Negative 2. It will work its way back up. By request, I will slowly make my graph. Cool. Now what I'm going to do is I'm going to sketch the next one. And this is where I start to lose people. So lean in and make sure we got this. The second graph goes all the way up to what value? And all the way down to? But the period is pi over 2. So that means it completes a full cycle within just one tick mark, doesn't it? So I'm not going to be super exact as I draw it, but I'm going to try to make sure I go up, come down, and return back up within one tick mark. Now, some people look at the graph and they say, well, that's just a bunch of garbage. That really doesn't, I mean, there's no way that the actual graph looks like that. Like, there's no way that we're even close to the actual graph. And what I do is I take out my calculator and I put in negative 2 sine of x. I put in 6 sine of 4x. And when I go to my window, I make my x min negative 2 pi, my x max positive 2 pi, my scale every pi over 2, my y min negative 6, y max positive 6, and y scale every 2. And I press graph. And when I do, you're going to see that you can compare these two and you can decide how accurate our graph is. Yeah, I think it's spot on. You didn't get, okay. Well, it'll take some practice. It is a 4-credit college course, so we're gonna have to stretch our learning a little bit. But you guys are really smart. You guys have the highest test scores, right? So you're gonna do great. Good job, everybody.